Yes, I'm very pleased to share our project at this Feature Store Summit. But actually, we usually do not call our project the Feature Store. Usually we call it like a database. Yeah, this is like the difference between like a KV store and a relational database. This is because our project not only focusing on the store, but we also really focusing on the real-time the feature processing on demand. Yeah, so today actually I would try to really focusing on this unique features, how we deliver the real-time features in milliseconds. So this is first we introduce a little bit background of the OpenMLDB. So OpenMLDB actually is initialized by the 4Paradigm, and the 4Paradigm is a company from China. It's offering the plentiful-centric AI solution. The OpenMLDB is integrated with the 4Paradigm's commercial product. It's called Sage. It is used in the Sage to define and compute real-time features. Then last year, we have decided to open source OpenMLDB. Then the community also can benefit from this project. So the OpenMLDB actually is a young, for the open source, it's a young project, but actually it already has been developed and deployed in many applications for 4 to 5 years. Yeah, before open source, it's already have been deployed in more than 100 applications. Then after open source, we also receive quite a lot of feedback and users from the community, like some tech giants from China, like Huawei, like Jingdong, also like the Pelaku it is in fintech company from Indonesia. So now let me talk about some background of this, the technical background of this project. So why we really need the real-time features for real-time decision making. So from our understanding, real-time features mainly refer to 2 points. The first one is the real-time data. That is, we really need the fresh data. We need to do the decision making based on the fresh data, not the data from the last year or not the data from last month. Probably it's just the last data, the latest data happened in the last few seconds. And the second thing is we need to do on-demand real-time processing. And this real-time processing really needs the low latency. In our requirements, or from the requirements from the customers, actually they really needed low latency, like the milliseconds. So this is like the example. The table is like the example of one of our users. This is like one bank for the application of anti-fraud. So they really needed the real-time feature processing like in less than 20 milliseconds. So actually, we can see today in the market, we have quite a few solutions to do the feature processing. But actually, we see that most of them are based on batch processing or streaming processing, like the Spark and Blink. But actually, even for the Blink, actually, we saw the latency actually will be very high. It's like hundreds of milliseconds or even seconds. But there is really few solutions talking about the hard real time that is like a few milliseconds to do the real time processing. So this is actually we need a better solution to this. This is actually what OpenMLDB will do. So now first thing, let's see what is the challenges of computing real-time features, why it is so difficult. So let's think about if we want to implement a machine learning application, let's say in practice. Okay, so what we do? So first thing is the data scientists will go to the project. The data scientists, they have the background of machine learning, so they know how to define the features, how to do the model training, right? So basically, they have the knowledge of the machine learning. So the data scientists, they like the Python, they like the SparkSQL to write the feature script. Their job, as long as the model can achieve high accuracy, their job is done. They don't care how the performance of the feature script online. So actually, the feature scripts written by the data scientists cannot go online directly because of like the low latency, like the high throughput, like the high availability. All these requirements actually usually cannot meet. So at this point, usually we have another engineering team. So the engineering team, what they will do is actually they will try to rewrite the feature script written by the data scientist using some other tools, like the database tools, like C++, to rewrite this program and make it really fast online. So their program can meet the requirements like the low latency, high throughput, and high availability. So actually, at this point, we already can see the cost to implement a machine learning application actually is really high. We need 2 teams, and we also need 2 systems, right? But actually, this is not the end. Another very important point is we need to do the consistent verification. That we need to make sure that the script written by the data scientist is consistent with the program written by the engineering team. So this verification actually costs a lot. Based on our experience, if you are trying to implement a larger, a really big machine learning application, it will take months to do the consistent verification. So actually, we can see the major challenge is one is the correctness. We need consistent computation logic between the offline and online features, and without data leakage. And also, we need to achieve efficiency. That is computing real-time features just in milliseconds. So how OpenMLDB tackles these challenges? So basically, we will look at this very high-level architecture. We will see inside the OpenMLDB, we have 2 engines. One is the batch SQL engine. This engine actually is modified, improved based on Spark. Actually, we have done a lot of source code modification based on the community version to enhance the performance as well as to extend the SQL syntax. And the other SQL engine is the real-time SQL engine. So this is really the key to deliver the high performance. Actually, we built this real-time SQL engine from scratch. We really think about the performance improvement, performance optimization, and based on the really focusing on the time series data, and also optimized for the feature engineering workload. So based on this the real-time SQL engine, we can really deliver the milliseconds latency. And between this, another very important thing is we have a unified SQL plan generator. This plan generator actually is the key to ensure the consistency between these 2 engines. So based on this architecture, so as long as data scientists, they can write the SQL script, so their SQL script can go online directly. So we can see that we can achieve this target. That is, data scientists do the offline development, and then they just use 1 command to deploy their SQL to online. And then we just prepare the real-time data stream, and then that's all. Your service is on, so you can do the real-time. You can do the on-demand real-time request to do the feature engineering. So let's recap. So the OpenMLDB in trying to tackle 1 challenge is to provide the consistent features for training and inference. And another thing is that we can compute the real-time features just in milliseconds. So let me just quickly go through some highlights of this project. The first one, as I mentioned, is that we have a SQL plan generator to ensure the consistency between the offline and online engines. This is actually we do some we have developed this SQL plan generator can translate the logic plan to physics plan to the offline engine and online engine, and also keep and ensure the consistency. And also we share some unified computing libraries between these 2 engines. So we can through this SQL plan generator to guarantee the offline and the online consistency and without data leakage. The second thing is very important is we can deliver these real-time features in milliseconds. This is actually we build this real-time engine from scratch. We have 2 very key optimization techniques. The first one is we have an in-memory double-layer skip list. This data structure is really optimized for the time series data for the feature engineering workload. And the second thing is we have some pre-aggregation techniques. That is, if your time window is very large, actually we can do some pre-aggregation to speed up your performance. So actually we compare with some these 2 figures. Actually we compare OpenMLDB with other commercial in-memory database. Actually, one is the SAP HANA and another one is a single store. We can see that for time series data, for the feature engineering workload, OpenMDB can outperform these two databases a lot. And this one, the second row is the figure about the optimization with the pre-aggregation. Actually, we have a paper. We have a paper at the top database academic conference, realdb. If you are interested, you can look at the technical details, how we achieve these real-time features. Yeah, of course, there's a part of the technicals. And the third thing is we want to emphasize these enterprise-grade features because this OpenMDB has been deployed in many enterprise applications. So we have introduced quite a lot of these enterprise features, like high availability, like horizontal scaling, like the smooth upgrade, like the monitoring and the multi-cluster. And also we are trying to develop more features for these enterprise applications. Okay, this is like a use case of our OpenMLDB, and Aqualak is the first users from after open source. So they are trying to build the ML ops platform and also to deliver the real-time features. So they choose OpenMLDB as the key component. So the result is like they do the real-time processing for orders within a day. And then usually for a day, they have like 1 billion orders per day. So now as a result, they can achieve the real-time feature processing like 4 milliseconds.